Hi, I'm Anna, and this is how to perform agentic retrieval augmented generation. In other words, agentic RAG. We'll need a few packages for this tutorial. Make sure to install the following libraries. Next, we'll import the following packages. Then, we input our API key and project ID. We've set up our credentials using a .env file. For this tutorial, we're using IBM's Granite 3.0 8B Instruct model, but you're free to use any AI model of your choice. The purpose of these models is to serve as the reasoning engine that decides which actions to take. We'll set up a prompt template to ask multiple questions. And now we can set up a chain with our prompt and our LLM. This allows the LLM to produce a response. Let's test how our agent responds to a basic question, like what sport is played at the US Open. Our agent responded correctly. Let's try something a little harder, like where was the 2024 US Open? The LLM is unable to answer this question. The training data used for this model is from before the 2024 US Open happened, and without the appropriate tools, the agent doesn't have access to this information. The first step in creating our knowledge base is listing the URLs we will be getting content from. Here are a list of URLs summarizing IBM's involvement in the 2024 US Open. Let's put them in a list called URLs. Next, we'll load the URLs as documents using LangChain's web-based loader. We'll also print a sample document to see how it loaded. Looks good! In order to split the data in these documents into chunks that can then be processed by the LLM, we can use a text splitter. The embedding model that we are using is an IBM Slate model through the watsonx.ai embedding service. Let's initialize it. In order to store our embedded documents, we will use ChromaDB, an open source vector store. To access information in the vector store, we must set up a retriever. Let's define the getIBM US Open context function and tool our agent will be using. The tool's description helps the agent know when to call it. This tool can be used for routing questions to our vector store if they're related to IBM's involvement in the 2024 US Open. Next, let's set up a new prompt template to ask multiple questions. This template is more complex. It's known as a structured chat prompt and can be used for creating agents that have multiple tools available. Our structured chat prompt will be made up of a system prompt, a human prompt, and our RAG tool. First, we'll set up the system prompt. This prompt tells the agent to print its thought process, the tools that were used, and the final output. In the following code, we're establishing the human prompt. This prompt tells the agent to display the user input, followed by the intermediate steps taken by the agent as part of the agent scratchpad. Next, we'll establish the order of our newly defined prompts in the prompt template. Now let's finalize our prompt template by adding the tool names, descriptions, and arguments using a partial prompt template. An important feature of AI agents is their memory. Agents are able to store past conversations and past findings in their memory to improve the accuracy and relevance of their responses going forward. In our case, we'll be using LangChain's conversation buffer memory as a means of memory storage. And now we can set up a chain with our agent's scratchpad, memory, prompt, and the LLM. The agent executor class is used to execute the agent. We're now able to ask the agent questions. Remember how the agent was previously unable to provide us with the information related to our queries? Now that the agent has its RAG tool available to use, let's try asking the same questions again. Let's start with, where was the 2024 US Open? Great! The agent used its available RAG tool to return the location of the 2024 US Open. We even get to see the exact document that the agent is retrieving its information from. Now, let's try something harder. This time, our query will be about IBM's involvement in the 2024 US Open. Again, the agent was able to successfully retrieve the relevant information related to our question. Additionally, the agent is successfully updating its knowledge base as it learns new information and experiences new interactions, as seen by the history output. Now let's test if the agent can determine when tool calling isn't necessary to answer the user query. We can test this by asking the RAG agent a question that is not about the US Open, like what is the capital of France? As seen in the agent executor chain, the agent recognized that it had the information in its knowledge base to answer this question without using any of its tools. And that's it! In this tutorial, we created a RAG agent using LangChain in Python with watsonx AI. The LLM we worked with was an IBM Granite 3.0 8B Instruct model. The AI agent was successfully able to retrieve relevant information via a RAG tool, update its memory with each interaction, and output responses. It's also important to note the agent's ability to discern whether tool calling is appropriate for each specific task. For instance, when the agent already had the relevant information needed to answer a question about the capital of France, it didn't use any tool calling for question answering.